Okay, today we're going to be looking at lesson 6-7 6-8, and this is exponential and logarithmic inequalities. So let's look at this first problem. So this first problem is in exponential form, but it's an inequality. And so the first step we would do to solve this, it would be to change to what form? It would be to change to logarithmic form, because remember, anytime we have a variable that's an exponent, we can change it to logarithmic form. So then we would have log base 8 of 15 is greater than or equal to 2x minus 1. Now, you might be wondering, why did I switch that sign? And you have to make sure the relationship stays the same. So right now the sign is pointing to the 2x, so it needs to be pointing to the 2x. Like that relationship between the sign and the variable must always stay the same. So 2x minus 1 is less than, so the same thing here, 2x minus 1 is still less than. So that's what we need to make sure we maintain that relationship. So if I continue to solve, I would take my log base 8 of 15, add 1 to it, and divide by 2. And if I type that in my calculator, I get that x is less than or equal to 1.15. So I'm just writing now that the special considerations is that we had to keep the relationship, once again, between the variable and the sign the same. So sometimes it means you're going to change the sign, sometimes you're not. You just need to make sure that the relationship between the sign and the variable does not change. Variable, put that backwards. Okay. So look at this next one. It's in log form, so we are going to change to exponential form, because that would be the inverse operation. So in this case, the base is 4 to the third power is greater than or equal to x minus 5. And once again, I had to change the sign because it was x minus 5 is less than. So it's still x minus 5 is less than. 64 is greater than or equal to x minus 5. Add 5 to both sides, and I get that x is less than 69. Now, because of this specific situation of the argument, what do we know about the argument? It must be greater than 0. So in this case, I need to also do x minus 5 is greater than 0, or x, that should be a 5. X is greater than 5. Okay. If you remember, this is the same kind of thing we did for the rational functions. I'm sorry, not rational, radical functions, because the radicand had to be greater than 0. So I have two parts here. So once I have these two inequalities, I graph them on a number line. So I have 5 and 69. X has to be greater than 5 and less than 69. So that means my inequality is 5 to 69. So once again, I have the argument must be greater than 0. That's a special consideration. And I had to watch the sign. So I had to change the sign so that the relationship would stay the same between the variable and the inequality sign. So for these problems, when it's in log form, make sure that you do 3 parts. First, you solve the log form, and then you solve the argument greater than 0, and then you graph it. So log form and go ahead and solve, change to exponential and solve, argument greater than 0, and graphing. Okay, there is another way to solve these problems, and you don't have to do it. It's just an option. So the way that I've just showed you on these two, you can do all of the problems on the homework this way. The next way I'm going to show you is just an option. I know some teachers have been showing their kids. It's important that you see it. It's not necessary that you do it this way. So don't let it confuse you or mess you up. The way I just showed you works for every single problem. Here's just another option. So in this option, hold on, there we go. we take the log of both sides. Okay, so when we do that, you're taking log base 8 of, log base 10, you're staying in base 10, of 8 to the 2x minus 1 is less than log of 15. And then using the power property, you move the 2x minus 1 in front as a coefficient of the whole thing. Then you divide both sides by log of 8. Then continue to solve for x. So then you would add 1 and then divide by 2. So the thing that makes this different, or maybe possibly easier, is I did not have to change the sign, but it does have an additional couple of steps that you have to write down. So I didn't have to change the inequality sign, but I had a few more steps. I get the same answer, x is less than 1.151. Okay, I can do the same thing, or the same idea with the other problem. And in this case, I would take the exponentiate both sides, so that I end up with keeping a base of 4 for both sides of the equation. So 4 to the log base 4 of x minus 5 is less than or equal to 4 to the third. And then because the bases are the same, that can cancel, so I end up with x minus 5 is less than 64. Then I add the 5, x is less than 69. I still have to set it greater than 0. I still have to do the graph, and then I get an inequality answer just the same as before. So once again, the argument needed to be greater than 0, and but I did not have to change the sign. Okay, so argument still must be greater than 0, but like I said, you didn't have to change the sign. So for the next on the back, it's time to try it yourself, and I would pause at the video at this point and try it to work them yourself. I'm going to work them the way I showed you first by changing forms. You may try it the other way, and I do get the answer key for both options. So let's see. Like I said, if you need to pause now, otherwise, watch them. I'm just going to kind of talk through them pretty quickly, but you need to try them first. Okay, so hopefully you've given these a shot, and now you can watch me go. So for this first problem, you would change to log form. Log base 3 of 18 is greater than 2x plus 3. This first one the sign did not need to be changed because it maintained the same relationship. So in the original problem, 2x plus 3 is less than, and once I change it to log form, 2x plus 3 is still less than, so I did not have to change the sign. Okay, for this next problem, it's base e, so it's a natural log, otherwise exactly the same. Natural log of 17 is greater than negative 9x. When I divide by negative 9, I change the sign, and that's because that's just my rule of changing signs. So first time I changed the sign was to keep the relationship between the variable and the sign. They're both pointing to the x in this case. And then the second time I changed the sign, it was because I divided by a negative. And that's just one of those rules that you learned in Algebra 1 about dividing by negative. So that's the reason for that. For the next problem, once again, just change it to log form. Log base 5 of 71 is less than or equal to x plus 2. I did not have to change the sign because the relationship stayed the same without changing the sign. So then I would subtract 2 from both sides, and x is greater than or equal to 0.469. Okay, for this next problem, I am going to change it to base e because it's a natural log. So e to the third is less than or equal to x minus 9. So when I add 9 to both sides, I get x is greater than 29.086. Now remember, I also have to do my part 2. X is greater than negative 9. Oh, that should be a positive 9 when I moved it to the other side. So x is greater than 9. And that's a 9. So, let's see. X is greater than 9, and x is also greater than 29.086. So in this case, they're both greater than, which means I need to find the part that both places overlap. So in this case, it is x is greater than 29.086. Okay, so it's not in between them this time. It's greater than 29 because they have to both. It has to meet both criteria, and the only place that does that is 29 greater than 29.8 or 086. Next problem. Change to exponential form. So the base is 3. The base is 6, and the exponent is 3. So 6 to the third. I had to change the sign to maintain the relationship. It's greater than 2 minus x. If I can continue to solve, I'm going to subtract 2. And then add x, and that would be the solution. And then subtract 2, subtract 2, and then divide by negative 1. So my answer is negative 214. I also need to solve the equation for greater than 0. So I get x is less than 2, but it's greater than negative 214. So in this case, it is in between the two. I do have a bracket because one of them is equal to. So there's my 3 steps. And I'll go back and show you the first time the 3 steps. So make sure you're doing all 3 steps for the log equations. And the last one, 7 squared, is greater than 2x plus 1. And then continue to solve by subtracting 1 and dividing by 2. And also do 2x plus 1 is greater than 0. Subtract 1, divide by 2. X is greater than negative 1/2. Okay, so once I graph it, I see that x is in between negative 1/2 and 24. And so there is my solution interval between negative 1/2 and 24. So, and once again, I did the 3 parts. 1, 2, 3. Okay, so the 3 parts are only when it's in log form because the argument has to be greater than 0. And like I said, the answer key, I have it go also with the other method of exponentiating and putting both, making both of them logs. So you can look at that if you would like to look at that answer key as well. Good luck.